really care, right? It's applying these things to a type of iGame object. So this is where we might have to, when we're going to refactor, we're going to take a look at, does everything thread the way that we want it to? Right now it might not. That's fine. There's a path to that. But we do want to see this in action. So let's go back over to here. All right. So we're kind of cheating as our game comes together. We are cheating less than we used to. Before, if you see all this commented out code down here, this was all us kind of just manually throwing things together because we didn't really have a good system for it, but we wanted to test it out. So it got really long, all this green stuff. We were trying out healing, and we're trying out fighting, we're trying out all kinds of things. Greetings, names, hit points. We did a lot. And then we started on the game engine, and now we can do all of that a little nicer. We still can't do everything. So let's go over to iPlayer. So, we're talking to the interface inside of our main method, right? We're casting the game object to iPlayer. And so what it's telling the runtime is it's saying, you can expect that this object has all the methods and properties that are defined by iPlayer. And we can do that because iPlayer derives from my game object. So it's a safe cast. And that's really important. It really underlines a lot of what we've done as far as the inheritance. Because we want that interoperability. We want to say, hey, everything in this game is an iGame object, so we can treat it that way. In this case, we also want to we will notice that the ability to set the state isn't here. So even though it's going to exist in that object, we're not going to have a way to get to it because it's not part of this contract. So we want to say set state. Let's go ahead and just come back over here and make sure inside of our player we got this guy, right? Actor state. Let's copy that. And so what this says is that every player should have a set state. Now, we're also going to have an iMonster interface in contract, and we might not have this set state as part of its contract. So we can see where even though things are inheriting and monsters and players are both actors, their implementation inside of their respective domains varies greatly. It's also the power of this polymorphism. And that is an exam question, polymorphism. Okay, so now we've got a way to get at that set state method. Come back over here, and we added an item to Gary, just fine. Good on you, Gary. Gary's a jerk. I don't know if I've said that enough times. I don't know why Gary is the name I chose for this person, what unresolved issues I might have, but he really is. And so, oops, we don't need to new it up. We can do actor or states. Disabled. I did pick the right career though, as an aside, because I really like it. Like when you do stuff like this, and it reads really well, and the intention is obvious, and things are strongly typed. It's definitely want more of that. Okay, so Gary's disabled. Whatever. And Gary decides to heal Beth, which is great. And then for whatever reason, because Gary Gary is such a jerk. He's going to try to hit Beth immediately after that. Why? I have no idea. So, what we're saying here is we want to execute a new game request. And then we're going to use an object initializer to define what that game request is going to be. So we want to say game action is equal to game actions fight. So the action we're requesting is fighting. You'll notice this nice IntelliSense and it's like the purpley stuff. That's all ReSharper. It's the only pay tool I'm using. You can get a license if you're a student for pretty cheap. You can do a 30-day trial. It's the one place where I apologize because I really like the idea of everybody being able to download the code from GitHub to grab a commit from any week they want and see how it all came along. And if you're watching the video, I know that can be jarring sometimes when you see things in my environment that aren't in yours. So I want to make a point of that as often as I can. That your fan says, damn it, Gary. I could not agree more. I could not. Okay, so we want to fight. Syntax says, poor Gary. Gary.add inventory item, new wheelchair. You guys are very fast learners. Okay, so once again, the sender is Gary. And once again, his target is Beth. So, for whatever reason, I need to do this guy. So we want to display that response before we execute the next one. And if you'll notice, again here, it says the value assigned is not used in the execution path. It's great IntelliSense there. So what it's telling us is that, hey, you assigned this value, and then before you used it, you reassigned it. Fair. And if you do use ReSharper, if you get these little hints and stuff, and there's these hints in Visual Studio as well, sparingly, and it gives you this little squiggly, you will become a better programmer or a great programmer 10 times faster than anybody else if you question every one of these squiggly lines. Don't just correct it. Don't just let, sometimes it'll be a hammer, sometimes it'll be anything else. Don't just let ReSharper fix it for you. Challenge that statement, and again, you will leap past your peers. Okay. So, we're going to request and then display. Request and then display. Alright, so we've done a lot here, and I love to run these things kind of just to see what happens. If it blows up horribly, great. But we've done a lot, and if it doesn't work, we're going to come back on Refactor Saturday and really dig into some of the code. But let's just see what happens. Ah, look at this. Okay, let's just stop it. It worked. So everyone gets a pat on the back, maybe a cookie. Let's just go ahead and pause it there for a second, because it's cool. It's super cool. All right, so we executed this command. We got back a response. Inside our response, it says that the amount was 5, and that the message is Gary heals Beth for 5 damage. Was successful, false. We need to fix that, right? So we want it to be true. So there's a small bug there. But it went through. Okay, so then over here, we've got our title of our room, our description. There's a lot of stuff in this, and when we render it, this is also great, right? It gets you the idea of rendering things, even in a text sense. So we're rendering a room. And we've got targets. One is Carl. He's a zombie. You wouldn't know it. And also here are Gary and Beth. And then we say Gary heals Beth for 5 damage. And then I write out, and I'm Gary, by the way, so we're writing out Gary's stat line. So Gary has quite a bit of health and way too many decimal places behind that. And then stamina in our world is going to be turns. So the idea is that you come into town and you've got problems to solve. And those problems can be solved by you healing, fighting, repairing, or negotiating. And every time, depending on your class, every one of those actions takes a turn. And we're calling those turns stamina. And so every time you do something, you'll see your stamina go down. And when your stamina hits 0, you have to rest. Well, if you rest without fixing everything, then the next day you have to fix those things and other things. So that's the game. But let's fix this bug real fast in the next few seconds after we look at this. All right, so I'm getting excited. I don't know if you can tell, but I had like an adrenal dump, and now I'm all like, yeah. All right, so next we want to fight. But remember up here, we disabled Gary because he's a jerk, and we know this. So we played, we played mean game master, and we disabled him. And then our business logic, if you remember, we said, hey, if you're disabled and you try to fight, you're just going to return back an error message saying you struggle to move. So we do that, and we display the response, and we say Gary struggles to move. Let's fix the fail stuff real fast and run it again. That's already really cool. So we've got the ability to use state, and we've got the ability to process commands. So we're moving along. We've implemented our new design pattern pretty easily, and also showed off some really cool stuff. Okay, so instead of our base actor, we've got this response is true. Ah, look at this. I'm saying look at this like you wouldn't be. Maybe you got distracted and you needed that. All right, so over here, we're still for heal. We've got it not setting them was successful because we did it a different way because we're trying to write this algorithm before we apply it to everywhere else. So what's successful equals true. Can you all hear my guard dog? I call him a guard dog. He is the gentlest soul in the world. But I moved into this house, and his like inner mutt is coming out, and he thinks he owns the place. And so when people walk around outside and make any kind of noise, he's just very like, who goes there? Anyway, so if you hear that, I apologize. I'll give him some peanut butter next time. Keep him occupied. Okay, so let's go ahead and run that again, now that we've got this returning true. Alright, so we stop here on our heal response, hit F10 to display it, bam, it's blue, right? It's the blue we want, because it was successful. Give that guy, and then Gary struggles to move. So, as you can, and we'll end there, and Ashkatai says I needed that. I was eating that cookie you said I could have. I did say you could have a cookie, and if you knew the sweet tooth I have, I was so generous with allowing that cookie, because normally I wouldn't even tell you there were cookies available. I just hide them for myself. So, okay, so I'm going to end it there. But it's, if you can imagine having a way to parse the commands that we'd be able to actually put in these commands, the screen would just fill up with things we're doing. And at some point, someone's going to die, and we want to be able to check that state. So we've given ourselves the very first footsteps towards